Yes. You came to the correct place. Yes, after searching, ultimately you will get all the answer of this type of question for propositional logic and predicate logic. What is propositional logic and predicate logic? I am giving you some challenge, and if you are able to do the question, then after doing it, you can leave this video. Just see this question. Are you getting stuck about this type of question? Like this is a question, this is another question. Here how to solve it? What are these? How to get the answer? How to get what is this symbol? For all, there exist, implies, where to use and, where to use or. You are getting confused, right? So if you are getting confused, then definitely this video is for you to know all the answer perfectly, and not only the correct answer, why the other answer are wrong. You have to understand that also, why the other answer are wrong. Someone will tell you this is correct answer, but you are getting confused, why this is correct, why this is wrong, right? So that's why in this video I will tell you the total understanding from basic to advanced level, all the basic concept. With that we will solve these all question, and after watching that your total concept will be clear from propositional logic and predicate logic, because propositional logic and predicate logic is a very important area from where so many questions are coming. Whatever exam you are preparing, if it is your college exam, UGC NET exam, GATE exam, any other competitive exam, in discrete math, this is a very important subject, and it is related to artificial intelligence also. That's why you cannot leave it. So let's start. Must watch till the end. Don't leave in the middle. If you are living in the middle, then your concept will be not clear. So let's start. So here you can see in the propositional logic, first of all, what is propositional logic? Propositional logic is working with true and false. Yes, there is no middle. How are you? I am good or bad. There will be no answer like that. I am so, it's going on. No. Either yes or false. Either true or false. There will be no in between result. This is propositional logic. So excluded middle means in between anything will be not there. Not false means true, not true means false. And here are some table we have to remember, and these are the table actually just related with the digital logic also. Same thing are here. 0, 0, 0, 1, 1, 0 and 1, 1. That is the OR. You did the OR, right? That is called disjunction. OR means disjunction. AND means conjunction. And we did that. PQ AND. This is the AND table. How this is working? In the OR table, when there was OR table for P and Q, when there is OR 0, 0, it will be 0, 0, 1, 1, 1, 0, 1 and 1, 1 will be also 1. That is the OR. That is actually we are writing in this way. This is the symbol of OR in propositional logic. Predicate law, in here the what is AND? AND is how we are writing AND. Same way, 0, 0 is 0. In AND, when both are 1, then only it is 1. That's why that is true. Instead of 1, we will write here true, and instead of 0, we will write here false. Actually, propositional logic, if you are learning through digital logic concept, and sometimes the problem can be solved, most of the time the problem can be solved in digital logic format also, because propositional logic, this type of symbol, we are getting confused. What is this? What is that? Other than that, if I am writing this one like this way, P bar plus Q, then we are feeling so happy, right? So this is one trick. Whenever you saw the propositional logic question, just change it into digital logic format. Like Boolean algebra, we will solve it. It's very easy for us. So here is something extra also. What is not there in digital logic? That is the implication and the bidirectional. Implication means P implies Q. Means if P is true, then Q is true. Like that type means if then. When we are telling if then we will apply the implication symbol. What is then double implication? Double implication is like if and only if. Because when I am telling that if today is Monday, then I will take the class. It does not mean that I am taking class means it's Monday. It can be any other day also. So here the problem is, if I am telling P implies Q, that does not mean Q implies P also. But in double direction means when we are dealing bidirectional double implication, then it is actually if P equals to P implies Q and Q implies P, both are correct. That's why if and only if. What is the truth table here? Here the truth table is very interesting. You can see when both are false, means P is also false, then Q is also false. If today is not Monday, I will not take the class. So both are false. That's why P implies Q will be true. Here if P is false but Q is true, it can be happen. It's not Monday but I am taking the class. It is another weekday, Tuesday, Thursday, Friday. It can be any day. I am taking the class. Yes. So when P is false, Q can be true. That's why it is also true. P implies Q. Now P is true. It is Monday. I am not taking class. It is false. Normally it will be false because P is true here. So you have to take the class. Right? So that's why it is false. True, true to always true. When both are true, the it is Monday, I am taking the class implies is true here. It implies implication is true here. So this is the truth table for the implication. What is the truth table for bidirectional? Bidirectional means both have to be same. That's why for false, false it will be true, and true, true also it will be true. These are the main truth table what you have to remember. So it is and, or, implication and bidirectional. Now here is another next important thing, that is P implies Q means what? P implies Q means not P or Q. This is a 5-star formula from where means always you have to apply this formula for solving propositional logic, predicate logic everywhere. P implies Q is not P or Q. This is, please stick in on your mind, everywhere it will be required. Now the next type of question are coming, what is called tautology, valid, identically true, satisfactory. What is that? I am telling you simply. Tautology or valid or logically true or identically true, these all are same. When it is, when all the combination is true, all combination true means any expression will be given to you, like maybe P or Q and P bar, like something. Then if I am telling this two truth table PQ, there are two variables. Using this variable, if I am putting in this expression, if for all combination I am getting true result, all the combination I am getting true result means it is true. Otherwise, another way also we can solve, just by solving the expression. If I am solving the expression P plus Q dot P bar, it is like that. After solving, if I am getting expression giving result 1, then it will be true. Otherwise, it will be false. Means then it will be tautology or valid. What is then satisfiability or contingency? Satisfiability and contingency means when you are solving this expression, if you are getting in the truth table, some of them are true, some of them are false, like this way, combination of true and false, then that is called satisfiability or contingency. When you are solving the expression, you will get a value in a terms of variable. Expression give any value other than 0 or 1 in a terms of variable, like either P, P bar, Q or PQ or something. It will be not 0 or not 1. It will be in a terms of variable, then it is satisfiable. What is unsatisfiability then? Unsatisfiability or contradiction means when expression gives result 0 after solving. How it is? P dot p bar, but the expression will give you 0. So when you are getting expression result 0, then that is called contradiction. This is simple. Now think, here there are called the disjunctive syllogism and conjunctive syllogism. What is that? Disjunctive syllogism, it is the format of syllogism. What is the format? Here actually whatever given in the upper side, there are two statements will be these are given true. And in the lower side it is the conclusion. You have to prove that from the given true, is it coming true also? Always. If it is the conclusion coming true always, then we can say it is valid. Otherwise, it will be not valid. So you can see here what is going on. P or Q is given true. Means what it is? Actually, P plus Q equals to 1. P plus P or Q given true. Means it is 1. Another one is also given, that is not P is true. So what is another one? Not P equals to 1. So what is P? P equals to 0. So if I put here 0 plus Q equals to 1. So what is the value of Q? Definitely the value of Q is 1. Right? So that's why Q is true. Yes, the conclusion is correct here. And that's why it is a valid one. Same way is there, that is P plus Q equals to 1 given, not Q is 1 given, means Q bar is 1 given, Q equals to 0, so P will be 1. And when I am doing conjunctive syllogism, what is conjunctive? It is given that P dot Q bar equals to 1. P dot Q complement means bar equals to 1. Right? And here the P equals to 1. So when P equals to 1 and its bar equals to 1 means what? Actually PQ equals to 0. So why it will be 0? Then Q bar is true means Q bar is 1 means Q equals to 0. So Q equals to 0, that's why PQ equals to 0. This is the conjunctive syllogism. Something is given to you, from the given thing am I getting the conclusion? If I am getting the conclusion, then that is called the syllogism is valid here. This is the format. Now we are going to another thing, that these are also three important, most important. P implies Q equals to not P implies not Q. It is inverse, it's not same. It's not same. When I am adding inverse, that is not same. That I am telling that if it is Monday, I will take the class. Not Monday, I am not taking class. No, it can be true. It's not Monday, but still I can take the class. So inverse is not same. P implies Q. I cannot say Q implies P. This is called converse. This is also not same. But the contrapositive, it is same. P implies Q equals to not Q implies not P. That is same. How this is coming? P implies Q means I can write not P or Q. I can write it. Now here you can see, if I am doing this one, not Q implies not P. What it will be? Not Q, because P implies Q is negation. So not Q or not Q. Not P means it is not Q or not P. So double negation means what? That is Q or not P. Now same thing I can write like this, because or see that here if I am writing Q plus P bar, that is same I can write P bar plus Q. Right? So that's why I can write here not P or Q. So it is same, not P or Q, not P or Q. It is not P or Q. It is same, means it is actually P implies Q. So that's why P implies Q equals to not Q implies not P. This formula, that's why every time you will apply this formula. And double negation means the same value, double negation means it will come to the same. So this is a very important, always remember this three rule in propositional logic. And these are the rule of logical equivalence. That rule is same as the rule of the digital logic. In digital logic, you learned that P dot 1 equals to P, right? And P dot 0 equals to 0. Even also you learned that P plus 0 equals to P. And P plus 1 equals to 1. Anything plus 1 is 1. Right? So that these are the identity law, dominance law. You know that. And idempotent law means when I am doing P dot P, that is P. P plus P, that is also P. These are the law. Double negation, P double bar equals to P. Commutative law also you know. Associative law means what? P plus Q plus R. I can write P plus Q plus R. That is the associative law. Same thing, digital logic. Think like a digital logic way. Distributive law and De Morgan's law is very important in digital logic also, in propositional logic also. When you are doing P Q bar, then it will be what? P bar plus Q bar. And when I am doing P plus Q whole bar, then it will be P bar dot Q bar. Right? This De Morgan's law is another one where it will be required for always simplification. And the absorption law is also very important. When I am writing P plus PQ, then it is actually P. P plus PQ. If I am doing P dot P plus Q, then also it is P. P plus PQ and P dot PQ, these are absorption law. So P plus PQ will be P only and P dot P plus Q also will be P only. These are the some very important. And another one, negation, that is P plus P bar equals to 1 and P dot P bar equals to 0. So these are the simplified rule, simplification rule what you have to apply for digital logic, propositional logic, everywhere. Now I am going to solve the question one by one. Please let me know in the comment who are here till now. Write down in the comment section. Yes, now we are going to start the question. Write down that yes, I learned the concept. Now we are going to start the question, so that I can understand how many students are actually watching this, right? So see, here is the question. Consider the following two well-formed formulas of propositional logic. F1, F2 is given. Which one is satisfiable, valid? We have to apply that formula. Which one is satisfiable? How to prove it? Here just same thing we will apply here. I told that, right? P implies Q equals to not P or Q. This is everywhere applied. So here think like that. This is your P, this is your Q. So what it is? Not P or together Q means it is also not P. Now it is what actually? P bar plus P bar. This is actually P bar plus P bar. So your answer will be P bar only. Right? So when it is coming only P bar, it is in a terms of variable. In a terms of variable means what? Is it valid or it is satisfiable? Which one? Tell me. Next one, how to solve this one? P implies P bar. So it will be not P or again not P, because it is my P, it is my Q. Here is or, then not P or P. Now P bar plus P bar, it is actually what? P bar plus P bar, that is actually P bar. Or means plus, it is double negation, P double bar, that is P actually. So it is P plus P means P only. So P plus P bar is 1. P plus P bar is 1. So you got here 1. Expression giving result 1. That is what? Yes. That's why it is valid. This one is valid and this one is satisfiable. So answer will be F1 is satisfiable, F2 is valid. Simple, right? Easy. Now do the next one. Now you can do it. Try it. You can do. Yes. You can pause the video and you can try. Yes, let's do. So what is given here? P double implication Q or Q bar. Q or Q bar means what? That is 1 actually. And Q double implication R means in the place of Q I can write R, in the place of R I can write Q. So from here two things I got. In the place of P I can write 1 actually, and in the place of Q R I can write vice versa. Now I need to solve this equation. How to solve? Let's try it what I am getting. So first of all I will write in the form of digital logic because it is very much good for our eyes. We are very happy. We are feeling very happy because these symbols are really feeling bad. When I am writing in this way, it will be easy for us. So I am writing in this way. P dot Q. It's done. Implication. Here the implication was there. Now after that we will do here P dot R plus S. This is here simple. It's done. Now see that, can I change anything? Is it possible to change anything? In the place of P I can put 1. So in the place of P I am putting 1. Here also in the place of P I can put 1 plus S. So ultimately what is coming here? Q implies R plus S. That is coming. Right? Q implies R plus S. Now can I apply this one as P and this one as Q? I can do it. This one as P. So it is what? Not Q or R plus S. Means what it is? Q bar plus R plus S. Right? Now you can see R double implies Q means in the place of R I can put Q. That is Q bar plus Q plus S. So Q bar plus Q is what? That is 1. 1 plus S. Q bar plus Q is 1. 1 plus S means 1 plus anything, whatever it is. 1 plus infinite number of terms, infinite number of variable, whatever it is, it will be always 1. Why it is? Because 1 plus 0 is also 1, 1 plus 1 is also 1. Is there any other possibility? There is possibility only 0 and 1. So 1 plus anything is always 1. And that's why for the time of simplification, try to get 1. If you are able to get 1, then you can do 1 only. So that's why this will be 1. And you got your answer. Your expression is giving result 1 means what it is? It is definitely true. Yes. It's very easy, simple, right? Now go to the next question. Here it is, if X then Y unless Z. Think it. You can do. Think it. Yes. So you can see here X and Y implies not Z. X and Z, this one and this one. What is the meaning? Think like that. If X, if it is Monday, then I am, if it is weekdays or if it is Monday. If it is Monday, then I will take the class. Unless I am ill. What is the meaning? It is Monday and I am not ill, then I will take the class. Is it or not? It is Monday, X, and I am not ill, so I will take the class. Yes, it's done here. So, this is your answer. Clear? Clear? Yes. Now go to the next. Yes. So this is the question where you have to do the, consider the vocabulary here. This is how, what is the model? How many models are there? What is model? What is model? Yes. Model is nothing. Model means if I am solving this expression, how many variables are there? We will make a truth table. Now in the truth table, how many true are coming? That are called model. So ma'am, there are 4 variables. I will create the truth table. That will be very lengthy truth table. It is like that. How we can do in exam hall? No need to do it. How to do? Think logically, think logically. Here how many variables are there? A, B, C, D, 4 variables. Using 4 variables, how many combination we can take? 2 to the power n combination always. So combination will be 2 to the power 4 means 16 combination. Now think that these all are plus, right? Means OR. In the OR table, what is going on? When all are 0, then only I will get 0. Otherwise, for every combination, I will get 1. That's why I will do 16 minus 1, 15. That is going on here. Because all will be true here. Only when all are false, then only it will be false. So do it logically. Think it logically. Tell me one thing. In this state, if I am doing here and then what will be the result? Tell me in the comment section. Let me know in the comment section. If in this place I am doing like this, then what will be the result? How many models you can create here? What will be the result here? I know, I want to know the comment section. What will be the comment section? Okay. See that here the question number, some different question number are showing because I copy the question from exactly from the question paper. These are the some question of UGC NET, some question of GATE. That's why this question number is showing. No need to bother. Just write down like that. These many models are possible. That is why I can get the answer. Okay. Now here this question. Do the question. Yes, do this. And let me check one thing. Technically, I am thinking, is it recording going on or not? Let me check once. Do it. Let me check. Sometimes I am doing that mistake also, that yes, ultimately recording is going on. Yes, it is getting my voice. Okay, good. So I am right. Sometimes I am also feeling crazy. Okay, do it. So here, do this one. How to do? A person who is radical and electable if he or she is conservative but otherwise not electable. What is there in if? Think it. Yes. The answer will be this one and this one. Ma'am, why this is the answer? Because see that. What is if? A person who is radical. A person is radical, that implies he is electable. So this is my P, this is my Q. So implies, who is implies? The person, if the person is radical, that's why the person is radical, implies electable, implies electable. There is another condition also, that if he is conservative, that's why if he is conservative, it is actually if and only if. The person is electable, then he is conservative, and conservative means electable means it is radical. So that's why this is correct. Why this is not correct, ma'am? It is telling you the person is radical and electable. That double implication conservative means here it will be a conservative person is always electable and radical. It may not. I told you always that when I am telling P implies Q means it does not mean Q implies P. A person is radical, is electable if he is conservative. So there is a person who is conservative, radical, that person is electable. That does not mean that every conservative person is electable and radical. That's why this is wrong. Now ma'am, how to get D? D, see that it is actually the implication going on here. What is the implication going on? R implies E, double implies C. It was there, right? So R implies D means this is your P, this is your Q. Inside the Q, what it is? Double implication means E implies C and C implies E. That is the meaning of double implication. And outside there is R. So it is your P, this is your Q. Means not R or this part. Again, this will be not R or this part. So it is actually the expanded format of B. That's why answer will be B and D. Clear? I hope this is clear. Now see that here it is another question that f equals to x. Some of my friends are not perfect. Some of my friends are not perfect. What to do? These are actually the predicate logic question. So I am telling you predicate logic. After that we will come to this. And these are some home tasks for you. You can do it. And this is the answer now. Now you can do this question. So this one is a syllogism. Do this one. What is a syllogism? How to prove it? Actually, these are given to you. When these are given, then what will be the value of y? That is you have to do. What is the value of y? P implies Q and R implies S. And it is given that P or R. What is this actually? Not P or Q and not R or S is true given to you. And another one is given that P or R equals to 1. So see that. This total is 1 means this part also have to be 1, this part also have to be 1, because and means when both are 1 then only it is 1. Now when P is 1 then P bar will be 0, then Q have to be 1. When R is 1 then R bar have to be 0, then S have to be 1. So what is the meaning? Either R or S, either Q or S are not Q. Either Q or S have to be 1. Otherwise I cannot get it 1, right? When this part is 0 it have to be 1. When this part is 0 it have to be 1. So that's why either Q or S have to be 1. Yes, got it. Now we will do the predicate logic. In predicate logic there is two things. One is there exist, another is for all. There exist means at least one element is true. Some of them or one element is true. For all means everyone is true. All the students of this class who are watching, they are the computer science student, right? Or they are the mathematics students, can be also, because in discrete mathematics is there. Those who are these, they are the discrete mathematics students. There exist means there exist some students, some are male, some are female. There exist, that is there exist. Some of them, and it is all of them. So all means for all. We are writing in this way. There exist means there exist in this way. Now whenever I am writing for all, there exists, then we are comparing with a variable. X is a variable. That variable will be compared with a domain. That domain is the class. So in this class, all students are discrete mathematics students. In this class, that is Px, some of the students are female. That is the comparison. Always we are comparing with a domain. In a specific domain we are comparing. So now here there are something what we can do. For all means lots of things are possible. All of them, for each, given any, for arbitrary, for each, for any. These all the meaning are actually for all. And we can write like this way. Another one is existential, that is there exist. So for there exist means at least any one of them is true. So many different way we can express that every student in the class has studied calculus. The same thing we can express like that for every student in the class that studied calculus. For every student X in the class, X has studied calculus. So if I am telling Cx is the predicate that X has studied calculus, then how to represent? For all X, Cx. This same thing we can represent in another way if we are trying to do for the total world. For every person X, means any person in the world X, if the person X is the student in this class, then they studied calculus. Then they studied discrete math. If I am telling The same thing we can represent like this now, for all x. If the student, if it is the student of this class, then they studied this calculus. Means I can say discrete math also. Got it? So it is a trick. Remember, whenever we are using for all, most of the time for all will be, we can represent in the there exist format. Means this implication format. Here only this is the trick. In this trick you can apply everywhere to solve the question. With the for all we can use the implication. And here whenever we are doing there exists, but here with the for all we cannot use the and. We cannot use the and with the for all. Because this meaning is different. This statement will say all the people are student and the class studied calculus. All the people throughout the world I am telling they are my student. No, right? That's why with the for all we cannot use and. But in there exist, whenever I am writing there exists, some of the student in the class visit Mexico. Some of the student in this class are female. Then we can say there exists MX. So MX means visited Mexico. This one we can apply and. There exists some, there exists X. They are the student and they visited Mexico. So with the there exist we can apply and. This is the trick. If you are able to remember, then so many predicate logic question will be easy. Because here only students are getting confused where to use and where to use implication. Where there will be if then condition, then we will apply implication, and where we are trying to combine two statements, then it is and most of the time with the there exist and will be applied, and with the for all implication will be applied. This is the trick to solve this type of all question whatever I shown you. Now you can see here that is this is when it is true, when all are true then it will be true. When it is false, when any one is false then it will be false. Right? There exists when it is true. If any one is true then it will be true. If everyone is false then it will be false. Now see, these are the three very important rules. If I am applying negation with for all px, then this will be changed to there exist and this will be changed to not px. If I am applying negation with there exists, this will be changed to for all and this will be changed to negation. And this P implies Q, actually not for all will be changed to there exist, and this one is changing to and. Why? Why it is? Because just expand it. It is not px or qx. Right? Now I am multiplying not. So negation px will be px only, and or negation will be changed to and. When I am negating or, means negation is doing with or, then it is changing to and this will be not qx, and that's why you will get this one. These three are very very important for doing the predicate logic. Right? So let's do now the equivalence of this one. Just now I told. Yes, you all are correct. Just now we did it. It will be for all and this domain will be multiplied with this one. Now see here, for all x, this one and this one not logically true. This one are not logically true. Which one is correct? Yes, both are correct. Because why? I am comparing with this domain. These are the domain of male. So all x are male here, or these are all x are female here. I cannot say there is a specific person I am telling and it is male or female. This is not true. Means this domain, it is according to this domain, this is according to this domain. I cannot say. Maybe these are the computer science student, these are the x are the computer science student, these x are the economics student. Now I am taking a person and I am telling no, it's not equivalent. Here also there exists x, there exists, so I am comparing with this px, here it is comparing with this qx. I cannot say and means both is true. No. These are also actually very important to rule of predicate logic. Note it down. Now we can do the question, some of my friends are not perfect. Some of my friends are not perfect. How to do? Yes, there exists x. They are my friend. They are my friend and not perfect. Ma'am, why this is not the answer? It is telling you for all, it is not some. So it cannot be the answer. Here I am telling not, here is no x. X should be compared with the domain. And this predicate is totally wrong. Here I am telling there exists, they are not my friend. The person have to be my friend. They are not my friend and not perfect. This is not implying this. The person is my friend, then only I can say it's not perfect. It is not my friend. How it is possible? That's why this is wrong. Got it. Now do this. Who are watching till now? Give me comment section. Yes, this time I am here, I am present ma'am, because from a long time I am talking, you are listening or not. Some real number are rational. How to do? Some real number are rational. Some real number. Yes. Some means there exist. It cannot be for all. Now, should I apply implication or and? I told that with the there exist, we should apply and. This trick will be applied. You can see. Yes, there exists x. This is the real x and rational x. Real x and rational x. It's done, right? With the trick, it's very easy. Otherwise, you will think that why it is not. Because there is no if then and there exists, we should not use this. You learn it. Now see, correct formula for not all rainy days are cold. How to do? Not all rainy days are cold. Yes, not all. It's not all. Not all means negation for all. That will be changed to there exist. Not all. Some of the days are cold, some of the days are not cold, maybe. So not all means that will be there exist. And whenever I am telling there exists, then it is a rainy day and it's not cold. You are telling here it's not a rainy day, it is not correct. Here I am telling for all, it's not correct. It is the correct one. Now the next one. Do this. Very carefully understand it. Tiger and lion attack if they are hungry or threatened. Tiger and lion attack if they are hungry or threatened. How to do? Here you all are doing a common mistake. By looking this and, you are searching the and symbol and you are doing here mistake. Yes, this is wrong. Why ma'am? Because see that tiger and lion means either tiger or lion, they will attack. It's not like that a tiger is hungry, it will call the lion, lion please come, we should attack. It's not like that. What is the inner meaning? Either it is tiger or it is lion, they will attack if they are hungry or threatened. That is the meaning. Understand the meaning of the student or meaning of the question. It's not and, it is or actually. So either it is tiger or it is lion. If it is, then they are hungry or threatened, then they will attack. Right? Why this is not? Because for all there exists. Attack, then it is opposite. P implies Q does not mean Q implies P. Because they attack, it does not mean they are hungry or threatened. Maybe it is for any other reason. Maybe you are attacking the child of that, or maybe any other reason can be also there. So we cannot say P implies Q means Q implies. That is hungry or threatened, then only. It is your P part, it is your Q part. This one is, that's why not true. And these are two. Definitely not true. It is not for all or. I am telling here all are or. No. It's hap. If then condition is there. If they are hungry and threatened, then they will attack. So with the or we cannot. Got it. This is a very interesting question. I hope you can understand. Now do this one. Yes. Not every graph is connected. Read the question very carefully. Yes. There was a not. Very carefully check that. It is does not represent this one. Which one does not represent this one? So not every graph means what? That is not for all. Definitely it is not for all. So not for all x. If it is a graph connected, it's true. Not all graph connected. Not for all is changing to there exist, so that's why it is there exist. If I am doing just solving it as P implies Q, then it will be this one, right? And not for all x, it's not a graph or not connected. That is also from here I can implies. But here for all graph not connected. Here I am telling all graph are not connected. No. Not every graph means some of the graph can be connected. So I cannot say that all the graph are not connected. That's why this was wrong. It is asking you does not represent means out of them which one is wrong. This one is wrong. That's why answer will be this one. Yes. Now this is a very popular question. 2 times this asked in UGC NET. You can see here. There is a country that border of Nepal, India and Nepal. What will be the answer? Think it. There is a country that border both India and Nepal. Yes. There is a country, and with there is we should apply the and. This trick will applied everywhere. Here it will be no there exists, it's not if else. There is a country and it is a specific country. That country is the border of India also, that country is the border of Nepal also. Here it is telling there is C border of country, it's totally a wrong predicate. It is also implies, here implies will be not. With the there exist, it is and. So that's why this is the answer. So it's now end of the class. I hope you understand everything. Predicate logic, propositional logic, how to solve. So many questions we solve there. These are the GATE question, UGC NET question. Most of them are UGC NET questions. Some of them are GATE question also. But whatever exam it is, but question are good quality question. And I hope after doing this question, your total concept is clear. So please let me know in the comment section and stay tuned with this channel, and I hope you did not forget to subscribe. So definitely subscribe to the channel. Stay tuned with me to get all this type of video. See you soon. Bye bye.